Alright, what's up guys? Welcome back to another paper. Today we're going to be doing our full first A-level paper. We're going to be doing AQA just to start off on an easier note. So we're going to start off with a little bit of a warm-up here with a log law question. And we're going to just need to get log base 10 on both sides in one expression. So we're going to simplify this down, so we can use the reverse power law on the left hand side, and we're going to use the addition rule on the right hand side. So and then we're just going to take away the logs, and we will expand the thing on the right and solve this quadratic, and we can find that you cannot do like log base 10 of -4, which means that that's not a correct solution. And that means that x equals 8 is the only solution, which means that the equation only has one solution. Right, next question. This is an algebraic fraction question. You can see from the denominators that they're going to cancel out because they're conjugates. So we're just going to multiply through like this. We're just going to do our normal multiplication for algebraic fractions. Going to combine the fractions, and then we're going to expand. On the bottom, we expanded the conjugate, so we've got a more simple expression. On the top, we've just expanded and got the negatives before a bracket. Next, we're going to expand the -1 and simplify. All right, next we have got probably one of the last easier questions. We've got an integration by parts question. You can see it just instantly. As soon as you look at this, you can tell it's integration by parts. So we're going to start. We're going to just write out the formula to remind ourselves, even though I think it's in the formula booklet. And we're going to set our values. So definitely set u to x because it's set to 1 when you differentiate it, and then set v dash to sine of 4x. So if we differentiate u, we get 1, and then we integrate sine 4x, we get -1/4 of cos 4x. Next, we're going to substitute all these in like this, and we're going to get this complicated looking integral here. But now the term under the integral is actually integratable, so we're going to do that. We're going to firstly take the -1/4 out, and we're going to integrate this, and then we are going to get this back. We're gonna expand, and then this is our answer basically. But we need to substitute pi/2 in because there's bounds on the integral, but we know that the lower bound is 0, so we won't have to we won't have to take away any other areas. So which means it equals -pi/8 when you substitute it in with your calculator. Alright, we've got this extremely long circle question here, which is also quite easy. So firstly, we're just finding the midpoint for 1 mark. Next, we're going to find the gradient for the question on top right up here, finding the perpendicular bisector. Going to find the gradient of PQ, 2/9, and then we're going to find the perpendicular gradient, so -9/2, put it in y equals mx plus c, and then substitute the midpoint coordinates in to get c is 61/2, and then we're just going to rearrange the equation to get our answer. Alright, next we're going to do this next part. Here's where the circle is introduced. So we have a simultaneous equation with the perpendicular we just created, and then this new line that the centre of the circle sits on. So we're going to do this, and I haven't laid out the working for the simultaneous equations, but I'm sure you can solve linear simultaneous equations without my help. So we're going to get x equals 5 and y equals 8, and then we are going to put them into this circle equation here. So we don't know r squared yet because we haven't substituted the any like points into it, but we do know that that the point of PQ passed through the circle, which means that we can substitute them into this equation to get the radius. So if we do that, we're going to substitute them in, so simplify down and get r squared. And this is our equation. So next part, we are going to just use a graphing calculator for this to see that that has 4 intersection points. Alright, Next, we have this weird trig question with compound like identity. So firstly, we're just going to write, so x is the initial distance between the floor and ceiling, is a c minus f, we'll use this later, and we just substitute 0 into that, so we're going to get 8 minus 4 sine of 0 minus, right, in brackets, 1 minus cosine of 0, that would just give you 8, because sine of 0 is 0, and then 1 minus cos of 0 is also 0. Next, we are going to do this next part. So this is very difficult. You have to use the compound angle formula. So firstly, we're just going to write this distance as we wrote earlier, as c minus f. And then we are going to write it out like this. We're going to just simplify it a bit. So now we have d as negative 4 sine of x plus cosine of x. I've just written it as x because it's easier, but it is supposed to be t. So now we are going to write it out like this. So we have b sine x plus d cos x. The d is not referencing the d up here. I know it's a bit confusing, but just the d is just an unknown number. It's not this d up here. So we know it's 4 and 1, but it's easier to express algebraically because we have a 1 here, which makes this next part harder if we use actual numbers. So we want it in this form here, cos r cos of t plus alpha, which I've just written as x plus alpha here. But we can't find that yet. But we can use the compound angle formula to get the we know that cos of a plus b equals cos a cos b minus sine a sine b. So we're going to write the second part of the equation out like this, where we've got the same b sine x plus d cos x, but we've written this bit out differently now. And we're going to distribute the r, and then we're going to equate the coefficients. So if we look at how many sine x's there are on both sides, we see that there's b sine x's on the left side, and we know that there is r sine a sine x's on this side. So we know that, no, negative r sine a, sorry. So we know that b equals negative r sine of a. We do the same with cos x now, so we know that there are d cos x's on the left side, and we know that there are r cos a cos x's on the other side. So we know that d equals r cos a. Alright, now we have a kind of simultaneous equation where we can divide both sides by each other. So we get b over d equals negative sine a over cos a because the r's cancel out. And now with the simple identity, we know that negative b over d equals tan a. I've just shifted the negative to the other side now. Right, next we are going to apply inverse tan to both sides. So if the inverse tan cancels out the tan on the a side, just to get a, and then that means that a equals inverse tan of b over d. But remember from up here, we know that b is 4, and we know that d is 1. So we can just write this out as tan negative 1 of negative 4 over 1. I think the b over d here should be negative, and we have a negative 4 here, so the double negatives cancel out. Sorry, I don't know, I kind of made a mistake there. This tan negative 1 b over d should be negative b over d, but and then we have a negative 4 sine x over here, so the double negatives cancel out, and we get a equals tan negative 1 over 4, and that equals around 75.96. So we have our a here, and now we need to find our r, which is a lot easier, because we know that tan of a equals negative b over d, as we see here. However, we also know that from these two, we can derive that cos of a equals d over r. We just divide by r. And because of these side lengths here, we can use trig ratios to know that negative b is the opposite, because it's opposite over adjacent. D is the adjacent, because again, opposite over adjacent, and then r is the hypotenuse, because cos a is adjacent over hypotenuse. So now, because we know that b is negative 4 and that d is 1, we know that r is just going to be the hypotenuse, so we use Pythagoras to find that. The double negative 4's cancel out here, so we just get positive. And we know that r is root 17, and we can write it out in this expression here. Right. Next, we're going to do this easier one. we know we're just gonna find the minimum value of cos of t plus 75.96, and we know that the lowest value that cos can be is -1, so we're just gonna assume that cos is -1. We don't have to find the value of t, we just need to assume that it's -1. So we need to have 7 plus root 17 times by -1, so just 7 minus root 17. And we can write this as an exact number in centimeters. Alright, next question. We have this break question here, which is very, very nice. So for part A, we know that the domain of arc cos is just the 90-degree flip of cos. So we know the domain of x is -1 to 1, just like the range of cos is -1 to 1. Therefore, the highest value of this is 1, so A is 1. Alright, for B, you just have to draw these curves. The only thing that they really care about, the examiners, is that the curves intersect at the same point. So we have this cos curve here, and we have this y equals x curve here, and they all kind of intercept at this point here. Alright, for the next point, the next part, we add cos x to both sides of the first equation. And then we say that when we multiply both sides of the bottom equation, this one down here, by cos x, we get just the top equation here. Therefore, they will have the exact same solutions, basically. All right. This next question is actually a lot easier than it looks for 7 marks if you know how to implicitly differentiate. So we know how to, if we know how to implicitly differentiate, we should know how to differentiate these terms. But we need to remember that differentiating for xy, you need to use product rule. So we're going to set u to 4x and v to y to get dy by dx of this equaling 4y plus 4x dy by dx. And then we'll just differentiate the rest like this. So the x squared differentiates to 2x, and then the 2y cubed differentiates to 6y squared dy by dx. Right, however, we do know that dy by dx equals 0 at stationary points when it's asking that is saying that p is a stationary point. So we know that 2x minus 4y equals 0 because this term goes away because it's multiplied by 0. This term goes away because it's multiplied by 0. So we can just leave by these terms, and we can rearrange this to x equals 2y. And now this is the easy part. We can just substitute back into the main equation 2y. And we can just simplify this into the thing that it's asking for. Alright, we got a final question here. This is a very difficult differential equation question. Well, it's always difficult if it's differential equations. So the first part isn't that difficult, but we're going to look at find the volume at a certain point. So if we look at, we have to just read all this before you start like watching, because it's a lot of like stuff to comprehend. So the volume at any point is going to be the base times by the depth, because the depth is a random point on this depth here, on this line, basically. So if it's halfway up, the depth would be 0.25, and then you would substitute this in to find the volume of water filled at that point. So we know that V equals 2D, and D equals V over 2. But now we find the differential equations. So the two things that are affecting it is the water being poured in, which is this here, where it's 0.16 cubic meters per minute. And the other thing that's affecting it is that water is leaking out, so it's a minus, at a rate of 0.36 d squared cubic meters per minute. So we're just going to put them both together to get the differential equation. Alright, and then we're going to substitute this thing we got earlier in and find our differential equation that's asking for in the question, and then we can just rearrange it to look like this. Alright. So next we have to do part B. So part B, II. So this next bit's really difficult. So we need to find t in terms of v, not v in terms of t. So we have to reciprocate the fraction to get this, which makes the integral 10 times harder because instead of integrating a top heavy fraction, we have to integrate a bottom heavy fraction. So with variables, which means we're going to have to use ln and absolute value, which is quite annoying. So next we're going to rearrange to form an integral like this, and we're going to factor 100 out. Now we're going to use partial fractions to separate these fractions here. You can do the partial fractions by yourself, but I haven't done the working because it's not that untrivial. And then we're going to factor we're also going to factor the 1/8 out of the top to get this. Right. Next, we're going to have to use the standard result here, and we're going to put this into this formula here. So the first fraction is going to turn into negative 1/3 ln of absolute value of 4 minus 3v, and the second fraction is going to turn into the same, but with 4 plus 3v. And then we have the plus c at the end. Alright, but we don't want c because it doesn't mention any bits of c here, so we're gonna have to firstly just take the third out to make it easier, and then we're gonna have to get rid of c. But we know that when time is 0, the volume is also going to be 0 because it hasn't started filling up yet. So if we just substitute the t and v, and remember all of this stuff equals t, I just haven't been writing it out, but from this first bit here, all of this stuff does equal t. So and then we substitute 0 into v, substitute 0 into t, and we get this expression here. And if we just cancel the ln 4's out, and we just get c equals 0 because it's doing 100 over 24 times 0. So now we can rewrite it just without c. Alright, next we're going to have to, that is kind of what the answer is, but next we're going to have to do the next two markers. So if we're finding the time it takes to fill the container, we know that the volume is 1 because it's just base times width times depth. And we're going to set v to 1, and then we're going to substitute that in and get minus ln 1 plus minus ln 7. I don't know why the plus is still there, but yeah. And then we're going to simplify this to get 8. Alright, that was a very difficult question. I mean, it was so difficult that I was just stuttering every 2 seconds. But anyway, thank you for watching, guys. And next time we will hopefully do an easier paper maybe, because that was very difficult. See you next time.